Interested in the latest developments for designing your virtual ECU? Don't miss the top 4 new features of vVIRTUALtarget. My name is Tanja and I'm the product manager for vVIRTUALtarget. In this video, I'll show you the top 4 highlights of the latest vVIRTUALtarget version 9. So let's get started. Our first highlight is the export of vVIRTUALtarget vECUs as functional mockup units. FMU 3 is spreading and aims to support the simulation of virtual ECUs. The layered standard LS bus finally allows providing bus communication for an FMU. Define your virtual ECU as usual in vVIRTUALtarget and make sure to check the option Export Functional Mockup Unit at the build tab. Additionally, to the standard system under test, you will receive the vECU as FMU, which is a packed archive. You can use the FMU in a lot of FMU 3 importer tools. Due to the standard, the FMU still contains less features than our virtual ECUs. No worries, you can still rely on all tools supporting our OpenSAT API, which is automatically integrated in the original vECU, or just use Canoe for simulation. Do you want to set up your CI system based on Bazel? vVIRTUALtarget 9 is ready for it. Bazel is supported by VTTMAKE, the command line tool of vVIRTUALtarget. To benefit from Bazel's optimization and caching, the workspace for the creation of the vECU needs to be structured. vVIRTUALtarget will take care of this preparation in a special Bazel configuration phase. Use a VTTMAKE file with Bazel project tags and start and call VTTMAKE config Bazel. Your vECU project folder will be prepared and the first set of files is generated. The build process of the vECU then takes place. For deeper insights, don't miss checking out our help and the Bazel sample. Maintaining multiple VTTMAKE files for one project just to change build or platform settings might have been tedious. Therefore, we introduced the feature of the Generalized VTTMAKE format. You can omit the build settings in the VTTMAKE file completely and define them when calling CMake. I will show you an example. My VTTMAKE file contains only the tag to generate a CMake project, but not how to build the project. I call VTTMAKE first to create the CMake project with all files generated by vVIRTUALtarget. And then I call CMake and specify the build settings. This allows me to change configuration, compiler, and even the target quickly. Another option is to integrate the build process already in your VTTMAKE file and override the configuration settings like debug or release when executing VTTMAKE. Let's have a look at an example again. The VTTMAKE file was configured for the Visual Studio Compiler 2022 in debug mode. When generating the system under test, I can now still override the settings and, for example, build the vECU in release configuration. Therefore, I just pass a new argument to VTTMAKE. Note that you need at least schema version 6.3 for the VTTMAKE file. vVIRTUALtarget is known to build a level 3 vECU for the Vector microsar stack. Starting with vVIRTUALtarget 9, our Vector virtualization service is ready to virtualize ECUs which are based on any AUTOSAR basic software, not just microsar. Just contact us at vecu@vector.com and we will discuss the details of your virtualization project with you. With these new features, we aim to simplify the virtualization of your ECU. We are constantly working on new features to support you to develop and test your virtualized AUTOSAR project. Feel free to contact us to let us know which features you need or if you would like a deep dive session regarding a particular one. Thank you for watching. Stay up to date on new features and get insights into vVIRTUALtarget and other Vector products. Just subscribe to our Vector Tech Tutorial channel and hit the bell.